Hi folks, welcome to Solara Technical. In today's video, I'm reviewing IEEE's 946, Section 5.2. In my last video, I introduced you to IEEE's 946 standard. The link's at the end of this video. As stated in my last video, 946 is the spec governing the design of DC power systems for stationary applications. Section 5.2 discusses system design considerations. As before, three subsections will be summarized: power generation, substations, and telecommunications. In addition to the loads requirements, any design should accommodate all regulatory agency requirements, safety, and specific customer requirements. In addition, it should address reliability, maintenance, testing, ventilation, floor or wall loading, and space limitations. The equipment being powered will govern the allowable operating voltage range of the system. Do you need a single voltage system or dual? For example, if the communication gear needs 48 volts and a 125 volt bus is available, should the communications equipment be powered by its own battery and charger system, or with a DC to DC converter fed from the 125 volt DC system? 946 suggests creating a diagram showing the batteries, chargers, DC panels, and all connected loads. Consider future growth as well as redundancy. The effects of special loads like inverters and DC to DC converters need to be well understood, as they will affect the DC bus from both current and voltage ripple standpoints, as well as its transient behavior. The most common DC system voltages in power generation are 24, 48, 125, and 250 volts. 250 volts is commonly used for motors on emergency pumps, large valve operators, and large inverters. 125 volts for motors, valve actuators, relay logic circuits, switchgear circuit breakers, smaller inverters, and field flashing. 48, 24, and 12 volts are commonly used for communication systems, instrumentation, and controls. Don't forget to calculate the voltage drop for long cable runs. Once the voltage limitations and design parameters are established, the size of the battery can be established as outlined in standards 485 and 1115, both to be reviewed in subsequent videos. Some battery technologies may exhibit a momentary voltage dip phenomenon known as coup de flaw or whiplash when supplying high initial currents. Be sure to check the battery manufacturer's datasheets. Also, a site restoration plan may require more than one attempt to restore the station's AC service. If required, be sure to design for this. Substations usually have a 125 volt DC battery system, so DC to DC converters are used to power the communications gear. Standard 1818 offers guidelines for such a situation. Telecommunications equipment operating voltage levels are defined in ANSI 600-315 and, as previously mentioned, are usually 12, 24, and 48 volts. As always, if you'd like help with anything related to power, please give us a call. We're here to help. Thanks for watching.